What's going on, everybody? You guys are laughing at my bots? My bot is out of control. I think I fixed it. Let me try it. Yes, I just needed to add that. I was trying to make it on a timer or something like that. Oh, it looks like I still have some formatting issues or something. This is kind of a little scuffed. But yeah, you have the Discord. I don't have the socials yet. We have !YouTube. If you want the YouTube channel, working on that. Some small improvements. Every day of the year, we get 1% less scuffed, 1% more professional. We'll get. So I think you can't keep spamming the bot like it has a timer on it. So every 20, maybe you have to wait like another 25 seconds for it to cool off, and then you could ask them for the Discord again or something like that. But yeah, we're making improvements. We're hanging in there. Give me gems. A robot takes over the screen control and displays a tip. Yeah, so it's Wednesday. Hope you guys are having a good halfway through the week, enjoying yourselves. So I'm gonna get back into doing some of this Who Lies stuff. I'm just gonna update the icon here. Let me see. There it is. Yeah, so we'll be doing just like a cloud kind of simulation today. If you saw on Discord or on the Twitter, I posted this kind of preview of it or whatever. Got a whole bunch of devs at my job interested in Houdini. What kind of devs are they? They're doing it's like game dev. But yeah, so we're going to be doing this kind of cloud convection simulation, cloud computing, Kubernetes, AWS is a different kind of cloud than this kind of cloud. Yeah, it's good to see Houdini spread. It seems like a lot of there's a pretty big overlap with people that do, like, I don't know, big data or whatever. Whatever, just working with big databases and stuff like that. It seems that I can't link my Prime because I'm in Sweden. Oh no, it's a embargo, the Bezos embargo. It's okay. It's not. We'll slowly build this channel. If you guys are, I don't want anyone to be stressing about subbing or doing bits or cheering or anything like that. Like, this is. If I just want to be able to provide this educational resources to everyone that so everyone can access it. But yeah, we'll be doing this kind of cloud convection stuff. So last Sunday, we did some. Just open that file up. We were starting with different techniques for sculpting or doing procedural noises, using Vex or VOPs to procedurally or programmatically, kind of with procedural textures. That's why I keep saying procedurally. Like, people call a Perlin noise, those function is like a procedural texture because it's not based off of an image map. It's just a function that runs, that generates a signal that creates a noise or a pattern. Yeah, so we'll just go, if you're on the Discord, it would just be the stream archive and then that latest file. I'm just going to open this up so we're working kind of roughly at the same scale. If you want to mix and match some of these techniques in the future, like just working at the same relative units or whatever, it makes it a bit easier, the same lighting and stuff like that. So we'll get started in a little bit. I'll just give people a few more minutes to get in before we start hammering stuff down. It's good to see everyone storming in here. We've got Steve GH, Brando, Jeff, Mistaken Tuna. Your entry or the cloud that Thunderhead you posted in the Discord was pretty cool. Naranjos. We got Alex, I appreciate everyone who's in the Discord giving me some feedback with that tutorial I'm working on. I'm still tweaking it and making some improvements and stuff, but it's coming along. I think it's going to be a pretty good. I'm trying to get it like as generic or for a broad audience that's not like super. A lot of this stuff I do on the stream is pretty technical or like advanced, but I think with those more long form or offline tutorials, I'm gonna try to just have them be a bit more approachable, even for someone without like a lot of programming knowledge or stuff like that. So we'll just get going kind of right now. I just wanted to talk a little bit. There's some interesting techniques and things like that that you can find if you look online and just search around. These are my own notes or whatever. This isn't a public document. But if you search for Surgeon Aaron Clouds, he's made a few posts. I don't think he's done like full tutorials and stuff, but just these articles. He does a pretty good job breaking down the cloud forces, like the different techniques or temperatures or like wind and stuff like that that causes things to look that way. I was just visually kind of trying to replicate something like that, or just looking at like cumulus clouds. It's basically kind of thermal buoyancy. So the hot temperature, or maybe these are like water particles, tend to rise and give you that cumulus kind of shape. Mistaken Tuna was more in this territory, doing the thunderhead, the anvil kind of storm cloud. But just looking at references and stuff like that is really useful, playing with clouds and doing all that kind of stuff. You get a lot of really interesting details and just the way that lighting hits it and stuff like that. It's kind of like you just can look at these forever, and it's a very valuable resource and stuff like that. So this is the main thing we're going to be thinking about or kind of replicating today. That's this atmospheric convection. So if you think of even like an atomic bomb or something like that, it's similar motion. It's a little bit different air, and like this is moving more slowly, so it's not as defined as like a mushroom cloud, but it's the same idea as this pulling things up, and then detail is introduced and kind of rolls off the top of it and down the sides of it. So this is just an alternate way to work, or another approach. Instead of directly modeling these like we did on Sunday, this is going to be doing simulation. So you get maybe more natural looking results, but it can be a bit harder to set up. You need more technical kind of knowledge with the simulation. But you have the advantage because you produce like an animation. So you could do time lapse, you could do a lot of interesting kind of things with it. So if you just search like cloud fluid dynamics or cloud motion, I don't know, there's a bunch of interesting researchers, like people working for weather stations, people doing physics papers. Like it's a pretty big, a pretty surprisingly big field or territory to study. I think somewhere I was there's some kind of like meteorologists or stuff like that that I follow, and this guy was recording some really cool kind of cumulus motion or rolling convection motion. I'm just gonna get rid of some of these windows. So I was like, this was some of the work I was doing on that grain crumbling tutorial. Umair, how's it going? Yeah, this guy did a really nice job filming this or whatever. Just seeing it's like hypnotizing. You can watch that forever. There's the like pyroclastic details. It's like kind of, it's like watching like popcorn in slow motion or something like that, or I don't know. But yeah, the lighting like at the evening, the sunset and everything it's amazing. Yeah, I could put the link to that guy's tweet if you want to follow him, or just admire this video some more on your on your own time. And I'm also just gonna stop some of this other renders and stuff that I've been doing. This was the tutorial stuff I was working on. Hopefully this will make my OBS just respond a little bit better. It won't drop as many frames, hopefully. Could get rid of this one as well. And I think we're good. Things are a little bit smoother. All right, so we'll get started with the actual meat and bones, the technical, the details. Yeah, so before we were working just in this kind of origin area or whatever, we'll just stick in that area, but instead I'm going to start with a grid, and this is going to be what we're going to use as like a base or a source for our simulation. So if I just do scatter, we can fill our grid or place a bunch of points on it. The default settings should be okay for now. What I'm going to do is just add an attribute VOP, and for this first step it's going to be pretty similar to what we were doing with the last Sunday, kind of getting the distance, a radial fall off, and masking stuff like that. Sorry, I am. What is the topic, by the way? Umair. It's so we're doing a simulation to generate or simulate a cloud formation. So instead of doing the noise-based kind of manual techniques, we'll be producing similar stuff, but using simulations or using DOPS, Pyro, and Smoke Solver, and all that fun stuff. So if I do the length of P, and then look at it here, this is just the distance from the center of the grid or the center of the scene. So we're going from 0 to 10, or just brighter numbers. And then I can do fit. So this just remaps the range. So if I want things that are just between 7 and 8, 0.7 and 0.8 units, we get this circle that's about like 0.8 units in radius, or maybe diameter, one of the two. So we might want to source min to be like 2.25 and the source max, I think I flipped it around. All right, so now we have a default circle. I'm not sure. You're asking about an older stream I did on the 6th, like a month and a half ago. If you ask it in the Discord, I think it'll be easier for me to follow up on it. I don't remember what happened yesterday, let alone a month ago. No, I don't know. Some of the older streams is just, it might be difficult for me to answer that question without taking time to go in and rewind it and inspect it or something like that. But this shape that we're making right now, this is going to be the base of our cloud, like the starting silhouette or the starting shape. And then if we don't want it to be such a perfect kind of slice like that, you can multiply things by a vector. So if you multiply this position by 3 float vector. If we just set all of these to 1, this is kind of like a transform doing a scale operation. So if I scale things in Z, you can see we could get a longer or slimmer kind of shape. So you might want to multiply this by 3 or maybe 2.5, just so our cloud isn't perfectly round, so it just has a bit of length to it, or just not uniform. We'll start with something like that. And then we can also maybe do just this anti-alias noise. So if I take this noise and generate a 3D noise with it and then add it back to the position, we're doing some distortion or warping of our noise or of our position distance. And then this way we can control, just get even more of like a non-uniform cloud shape. So instead of the default circle, we're just doing some deformation, distortion, or whatever in scaling to give us a little bit more of an interesting base shape. And then maybe we want to promote these 3D offset parameters. This way you could just type in different numbers here, kind of like a seed, to get different results or different interesting distortions. Black Cuckoo, how's it going? So we have our particles, we've turned some of them white and some of them dark. Gamma Bassoon, thank you for the tier 1. No worries, we're still kind of just getting ramped up. I've only placed 3 nodes, so you're not missing too much. We multiply a vector with another vector. What is technically happening? It's essentially a scale. Like if I just do this file, sometimes I like to use this and I just switch it to defaccess.bgo. You can put that in your Houdini. Any Houdini will be able to follow or pull in or read this geometry. It just brings in a template, like standard kind of axis or origin. So if I do a transform node, these translate, you define or you apply a translation by adding numbers to the position. So if I add like 0.1, this moves it over by 0.1 units. So that's a translator. Some people call it an offset to the position. And then the scale is a multiplication. So if I multiply the x vector by 2, this is what kind of like multiplying vectors is like, this is a vector of 2, 1, 1. So you just kind of break it down into each component of the 2 vectors get multiplied together as scalars. Does that make sense? So if we look at our spreadsheet, all of these x values here, they just get multiplied by this number. So if I just do like always on top, if I do 4, you might have to make a different spreadsheet from this one. Do always on top. So if we go from 4 to 2, you can see these numbers get different results or different values. So this is basically just sitting down and doing each component as its own kind of multiplication. Yeah, it's hard to find information for all that stuff. I think if you search like vector math for games, you might be able to find some good results. Trying to put together on my website, like I'm trying to compile a list of resources that are pretty useful, but I just haven't had a chance to get it together fully yet. So we're just doing our scale and distortion or warping. We're doing both the addition and multiplication here to do a scaling, and then this is an offset or translation, but instead of uniform translation, we're doing a varying translation based off of the noise signal. So spatially, the translation is shifting as we move around because we're using a noise. Yeah, I guess that might be, dot and cross is a little bit more advanced. Like you might, I'm not sure what you would want to search for, but vector, like vector, if you just search for vector addition, then people usually cover that and then go to vector multiplication next. But yeah, I'm trying to find a little bit better resources or just a nice list of websites that people could go and find that information. So we have our points, scattered them on the grid. When I scatter them, yeah, I showed you now, but it's nice to have a little notebook, or I don't know. I usually keep a little list of documents to refer back to. Sometimes I sometimes forget it myself. So if we go to output attributes, I'm just going to turn on p-scale. If I press the D key, we go to geometry and disks. This p-scale will store the spatial separation of the particles. So if I do decide to go in and make more particles, the p-scale will automatically adapt so that these are always spread out pretty well or non-intersecting. So this just assigns the p-scale radius, and then we assign the color value based off of our noise. What I can do with the blast, we can just delete things by color. So we just switch this to points, and then you can use attributes directly in this group field. So this will use the attributes and make a temporary group and do the deletion without you having to do more nodes or whatever. So if I just do, if the color, the X component is less than 0.1, delete it. You can see we're clearing out all of those darker points. You'd also switch this to red, like cd.r. If you're working with colors, it's maybe a little more straightforward for you. Yeah, so now we have our particles and the color. Halo Mike, thank you for the Prime. Need to get the Halo theme song going again for that one. The Gregorians in here getting their chant going. So what I'm doing now is using this attribute wrangle, and I'm going to make an attribute based off of the color channel. So I'll set temperature equal to the red component of the color. So basically, if you remember the reference clouds that I was showing, we're doing a cumulus cloud, or we have buoyancy, things rise, and that's what causes the overall shape of the cloud. So the stuff on the perimeter or the outside, it might not be as warm, so it's not going to rise as high. So we have points with color, position, p-scale, and temperature. And I think we're ready to start our simulation. I'm just going to clear that out, simplify things a little bit more, and maybe just do an attribute rename to clear up some of this stuff. So I don't need the color anymore. I only need these for what I'm going to do with the simulation. And then I'll just make a DOP network. This is going to be the pretty much standard Pyro or simulation workflow. If people watched older streams or whatever with the way that I set up these DOP networks, this is pretty standard. So I use a box in this other input. This one I use to specify the domain bounds. So just the container that our simulation happens within. If people are newer, they're interested, or they're curious about the sparse Pyro. I don't use that too much just because it doesn't support OpenCL or doesn't support GPU simulations. It only supports CPU simulations, which are pretty slow for Pyro. So I'm keeping things with the older kind of OpenCL simulation style just because it gives me faster results. So we have an empty template for our simulation now with this .NET. We're in the dynamics context. So with the tab menu, everything changes with our nodes. So we can make a smoke object. This is going to hold our pyro or our gas. Do you think it will work with OpenCL? I think maybe one day it might work. If you look at the sparse, any of their sparse solvers under advanced, they still have the checkbox. But if you read the docs, they basically say that turning this on disables the sparse nature of things. I think that if you talk to a programmer or an engineer, there's a lot of trickiness or things that make it difficult to port sparse pressure solves to work on a GL or whatever. New to Houdini, some advices to start. I think in the Discord there was someone that recently asked for like starting resources. If you do !Discord in the chat, there's a link for it. And then I think just in the questions channel we were giving some pretty good starting points. Let me see. Yeah, so you just go to the questions channel. This is from like yesterday or a few days ago. We gave some pretty good slides and files and stuff like that. This one's from Matt Ebb. He posted it on his website, or I can just put it in the chat as well. But yeah, there's a lot of different kind of resources depending. Certain ones might make more sense to you depending on how you're approaching it, whether you're coming to Houdini from a more artistic background, like just having an eye for design or modeling or animation, or if you're coming from it from a more like mathematical, technical background. There's kind of like different paths that you might want to follow or whatever if you're picking up Houdini. Please subscribe to the channel. I got all the bots in here. They're fighting over each other. Edvino, how's it going? So I'll turn on the OpenCL. I heard Bolsonaro got corona for the 3rd time today. So I usually switch these advection methods just because I find that these higher order stuff handle velocity advection or just give you better results. They're a bit slower if you use the CPU, but for OpenCL, it doesn't really matter too much. Still positive, good that he can't keep out and do crazy stuff. I don't know if does it mean that he's just still has it, or he's actually had 3 separate cases. I'm here from 3ds Max, Umair. I was actually using it. 3ds Max used to have a free version called Gmax. It didn't have a lot of like other features. It was like a simplified version, but I was using that like a long time ago when it was free. So I was using 3ds Max, but I haven't used it in like 10 years or something like that. So we just have an empty smoke settings here. I'm just gonna type in some expressions to get our bounding box information from the input to the DOP network. Really nice. Now you are complete on Houdini. Yeah, I mean, it was a long time ago. It was in high school when I was learning 3ds Max, and then during college, our college course was set up to use Maya. So I learned a bit of Maya, and then I kind of knew that I wanted to head in a more technical direction. So that's why I ended up settling with Houdini. I knew 3ds Max, you could do like Max script and kind of make some procedural instancing setups and stuff like that, but they had the node-based like p-flow for their particle systems, and I knew that node-based stuff was pretty powerful, but yeah, overall 3ds Max has some pretty bad habits that they'll teach you. But it's nice, especially for like architectural, like the viewport in it's pretty good, especially the integration with V-Ray. Like you can visualize all the textures and stuff like that pretty easily. So I'm just doing these expressions that's basically saying from the parent node, go to the last input and give me the X size of that geometry. So this is just referencing this box. I do it up here just because I can use these tools if I want to change the simulation container dimensions. So we can just keep going with these expressions. I'm just doing Control-C, Control-V to speed up the typing. And for center, we can do the same thing, but we just want to get the centroid instead of the bounding box information. And then instead of size, we can just get the individual components like that. So this is a bit tedious or whatever, but it's just a habit. It might be a bad habit. I don't know. It'd be nice if they just had a drop-down menu, like some of the new RBD tact objects. They start to have these drop-downs. Like it'd be cool if they did that for here. That was like domain properties or domain source or something like that. Dr. Robotvinik. Really enjoyed the VOD on cloud stuff. Thanks. Just wondering, do I ever work with Blender? I was using it a little bit for Eevee and to try out some stuff like that, but I'm interested in trying it out. I just haven't really had the time, or it's been hard for me to keep learning it, I guess. But it seems definitely to be improving and getting a lot better recently. So we'll do this multiple solver. There's this one guy like Mitch or something like that on YouTube. He does some streams and he demos like some pretty cool procedural setups or stuff that he creates. That's like kind of VJ stuff for concerts or different music videos and stuff. But it's seen really cool stuff being made with Blender, and then with Eevee, like it's interesting because you have a real-time engine and everything in all in one setup. So I just do a multi-solver. This just lets me do a step before the smoke solver runs its tasks or its inputs. Is RST release date, anyone? Nobody knows. I think the developers they keep talking about it in the forums. They say they're busy working on it, but they haven't given a solid release date or anything for it. So I'm just putting a SOP solver in with the multi-solver, and I set it to use external SOP, and then I use the same up input path expression, but this time to get the primary input. Then if I go back to the smoke object, and I switch this to solve on creation frame, now you can see we're getting our particles imported into the DOP context or into our simulation. What do you think about real-time rendering? I'm all for it. I'm all for anything that helps people work quicker and get better feedback. I think that's kind of why I stopped using Mantra and switched to Redshift, just because it's like trying to produce work, especially as a freelancer, independent artist. You just don't have enough time in the day or enough resources with the render farm to work more slowly. Shades of Orange, thank you for the tier 1, the 2 months. I appreciate it. So we have our particles that we brought into DOPS. And then right now, if I play, just show the timeline. If I play the simulation, nothing happens. The smoke solver or all of the volumetric solvers don't know what to do with these particles. They don't affect anything, basically. So to have these drive the simulation, I want to use them to provide a buoyancy force. I'm just going to use gas particle to field. And the reason I do this in the DOP network instead of at the SOP level, there's like rasterized particles and stuff like that. volume rasterize or rasterize attributes, a bunch of different ones. I believe it's a little bit quicker if you're working with the GPU. To basically this, I think the volume gets constructed on the GPU, whereas building the volume outside of the DOP network, it gets built using or stored in your computer memory or the RAM, and then it has to get copied or transferred over to your GPU RAM if you source a volume from SOPs into DOPs. So sourcing just particles is pretty lightweight information. Particles just take up a few kilobytes, but volumes take up a ton of memory. So that's the reasoning for doing this. And then we have the particles, and they're getting stored in the geometry data of our DOP network. You right-click somewhere and do spreadsheet. You should be able to see that, like, we have the smoke object, and then it has its geometry data, and these are the particles that we've sourced in or brought in. So I can just use these to affect or bring them into the temperature field. The attribute, this is what I was doing with the color, copying it over to the temperature attribute. If you middle mouse button, you can see we have position, scale, and temperature, P-scale for particle scale. And here, use attribute, I just copied that and I can paste it. We want to use the temperature. We don't want to use extrapolated. It will use the P-scale by default. I can turn on this magenta cyan flag to hide the particles. And then if I go to smoke object, I can turn on my temperature visualization to see this. We could also, just going to keep going for a little bit. So I want to add these to the temperature field each frame. So if I play the simulation now, you could see we're getting our particles brought in. They're providing hot air. We have the upward buoyancy. We have a very primitive method of doing this. It's a super low resolution. It's like a Doom video game sprite or something like that. So if we don't want to get rid of the slice, if you just go to the temperature instead of use plane, use smoke. So now we're actually visualizing stuff in 3 dimensions. And then if I middle mouse on the smoke solver, you can see our volume resolutions are really low. This is like this is like you have 20 Lego bricks in one direction and you're trying to represent a volume using that. You can see like the blocky artifacts pretty clearly. So we just want a little more detail, not crazy high, but just enough to be able to see stuff a little bit better. And then if you want to change the smoke solver or the smoke density, you can do it like that. The lighting doesn't ever really work inside of a DOP network, or I've never been able to get it to work. So what I do is just go up to the top level in the viewport, and we'll bring in the temperature information, and then I can adjust it with a primitive node. I'm gonna switch this to the Pyro. Where is it? Post-process. So this is a newer way to change visualizations of stuff. I can just take temperature and bind it to density, and we get the same idea. And I'm just going to do a VDB convert to go from a sparse Houdini volume to a VDB volume. So this just makes it a little bit easier for the viewport to display a sparse volume instead of a dense volume. I have the view pinned and can work up here now. Then we'll just keep going at a little bit lower of a resolution, kind of like high quality volume. The Pyro post process is just for visualization. Zeit editing. But it has a handy script kind of thing built in at the bottom, create matching material. So if you're working with Mantra, you can just click this and it runs a little macro script that makes you a pyro shader in a material network and transfers all of the settings. So not only is it a little bit, I don't know, more advanced, you can do some more interesting like visualizations with it, but you can very quickly use it to render things, which is a bit of a gem. It's a nice little trick. I think it's new in Houdini 18. Like I didn't realize it right away, but I think someone pointed it out that it's pretty useful. You could even do things, I guess I could get rid of this and then just using this I can do convert to VDB. And now we're still changing things to VDB. This 16-bit float is pretty nice. If you're saving stuff to disk, it reduces the file size. So instead of before I was using like 3 nodes, this is just a bit of a, you double click on it and check it out, what's going on inside, but it's just a handy shortcut or a little wrapper for tools and stuff like that. So our stuff isn't that good. It's pretty blobby. This is like a children's book, Toy Story Cloud or something like that, that maybe looks good for a video game if it's really far from the camera, but we want something looking a bit better with more detail. So we go to the smoke solver. A few issues here is temperature diffusion and cooling rate. Temperature diffusion is basically blurring the temperature every frame. So if I turn that off, then you can see it's preserving more detail from the particles. So instead of all the temperature values blurring together and we get a smooth plume or a smooth hot air or group of air rising up, now we get a more interesting, it's just preserving more detail essentially. So we don't want to diffuse the temperature that much. Using smoke solvers with like a grid base or voxel based thing, there's already a lot of blurring that happens from every frame, like due to advection and stuff like that. So you basically don't even, you want to preserve as much detail as possible. You think fluid volume sop, which is hidden now in Houdini 18, was good? I don't think I really used the fluid volume sop. You're talking about the fluid source? Like I know with the old fluid source node, you could use it to create volumes. But I'm not sure. If they do hide a node, like that was really useful, you could email them and ask them. Like sometimes they've hidden ones that people were using quite a bit and then they went and unhid it. Or you can unhide it yourself, but I tend not to do that just because it's like not a great idea to be, especially if you're streaming or teaching or working at a place, other people open your file and you're using a bunch of old nodes. They might not be too happy with you. This buoyancy lift, I'm just going to go to 1. So we're just that's just the overall like lift or thermal buoyancy, how quickly temperature causes things to rise. And cooling rate, I'm going to go a bit lower, or I'm going to go a bit higher with that, which is going to more quickly reduce the temperature over time. Yeah, I think that fluid source node could be pretty slow for a lot of situations. I would use it sometimes, but I don't know, it just seemed to be a pretty big pain. And then if you look, like you see, we get just a bunch of worms, kind of, a bunch of streamers creating our volume. So what's happening is every frame, these particles are getting sourced and adding, yeah, we're getting cloud trees or a fountain of clouds or something like that. So every frame, we're bringing in and adding more heat to our fluid simulation. So if we don't want to do that, you can use this gas intermittent solve. And then if you just set it to only once, this is like only source or only do these operations at the start frame, like just for the initial value. So now you can see we're just bringing in our temperature data one frame and then leaving it. So this is going to be a little bit more realistic or easier to control for kind of making a cloud. We could just go up because we're bringing in less temperature, like it's just being used for one frame. If I multiply this by 45, this value will come into the DOP network at a hotter temperature, which changes the look, the values, and the fading of everything. We might want to do, you would do like a power function. This is kind of like a gamma, so that the edges won't raise up or travel up as fast. You can bring some frame, then only one for 10 frame or less. How did you change the temperature for one frame? Just this gas intermittent solve node is one way to do it. There's a bunch of different ways you could do this kind of stuff. You could do like a switch solver. You can do maybe the enable solver. If you want to, you can do things this way, like $SF equals 1. This is kind of like the way that standard particle simulations work. Like if you do the pop source node with birth impulse activation, people will usually use that same $SF equals 1 here to say just emit or just source on the first frame. Sometimes I use this because it's fancy. Makes people think you're smarter. It just has this checkbox that's an easy thing to type, but saying only once is basically the same idea as saying $SF equals 1. And I'm just going to make more particles. And I might actually just get rid of that p-scale stuff. Let me think. I'm going to turn that back on. And then I'm just going to do an attribute noise. This just lets you run a noise function over attributes. So by default, this is going to change the color of things. Just an additive color. So we start with white and it's adding color to the points. I'm just going to switch this maybe instead of 3D to 1D. And instead of changing the color, change the p-scale. And then it's a bit too drastic. Like if you want to change that amount of things that it's adding, you could do the amplitude. Center noise is nice because then it will make things not only just bigger, but also bigger and smaller in certain areas. Maybe this is just like the frequency of the texture for the noise function. Something like that could be nice. And we might want to do the same thing if I just go up here. We can do another noise, but this one I'm going to do CD for color and do multiplicative. This will kind of will trip you up, that one. So what this will do is instead of maybe center noise, I'll leave that amplitude at 1, and then turning that off is basically the midpoint of the noise is 0.5. So you see the difference there. The reason I moved it up there is because we're assigning temperature based off of the color value down here. So we want to change the color and then assign it to temperature, and then p-scale, you could adjust it as well up here. Maybe it makes more sense to have like all your noises and then your final steps at the bottom. So now if I play things, we get a little bit more interesting results. Like the temperature isn't uniform. Certain areas are raising up quicker than others, giving us like a silhouette that's kind of more broken up, like a cloud. I'm gonna go into this wrangle, and I'm also just gonna do p-scale times equals. That just means like multiply the current value by 2. So this just says make the p-scale twice as big. Whatever they currently are, multiply it by 2, and then assign that result to the attribute. So because we make them bigger, this boosts the density, the temperature, because we have the same temperature value taking up a larger radius or a bigger p-scale. We produce just a greater temperature force overall, or more buoyancy. So now you can see we're getting somewhere. You squint your eyes and zoom way out, we have something that looks a little bit more like a cloud. But one big issue here is the temperature fades out and disappears. So we're using cooling rate to basically cause the thermal buoyancy to drop off or die off over time. We could change the cooling rate to not have that happen. It's kind of valid, but maybe you want your clouds to slow down over time. So instead of kind of changing this value, which also directs the look of everything, what I usually end up doing is if you just hold Alt and click on the particle to field, we can take our particles that we're bringing in and putting into temperature, and I could turn off use attribute, and then I can move these into the density field. So what this does, if I go back to the bottom and go into bindings, I could go back to visualizing the density, and then instead of bringing in the temperature, I can bring in the density. So we're basically using the density like an alpha or just an extra field. So it doesn't affect the movement or the motion of the simulation at all. It just gets tracked with it, or it just gets pushed around by it. So now we can change temperature however we want, do whatever we want to it, but visually it's decoupled or separated from our visual results. Just kind of helps you work that. Just unlinking things that you don't need to be relying on. And another thing I sometimes do with these particle to fields, if you bring the threshold way down, instead of each particle bringing in like a blurry fall off value, like it will be 1 at the middle and 0 at the edge, changing this threshold all the way down makes it just a constant value throughout. So you'll get a little bit better results at the end. Does that make sense? You can do a slice. I think so, visually it will make more sense to people than with me trying to explain it. So you use this slice is a nice way to inspect values. If I increase the maximum here, this is just setting the white point or the red point essentially. And then if I go back here, we're bringing the density field in. So if I change this threshold, you can see kind of what's happening. With it all the way up, it's saying like at the center of these particles, treat them at the full value, and then interpolate or fade to 0 at the edges. If I go even a lower resolution, it might be a little bit clearer. Some of these particles aren't like really lined up with this slicer. So changing this threshold value, this is basically what it's doing, is instead of going kind of like a blurry representation of the particles, you go very close to 0, and then you have this harsh contrasty thing. It's like either 1 or 0. You might think that that looks bad, or you would want like smooth interpolation, but for the final simulation, again, like I said, the smoke solver, like we don't want to do any temperature diffusion. We don't want to blur stuff. We want to keep it as crisp as possible. Things with volumes already get blurry in general, so you don't really want to introduce extra blurring if you can. So we're in better shape now. We got some mushrooms. We got some differential kind of buoyancy or thermal buoyancy strength because we're modulating p-scale and temperature by noise functions. So we can define different areas that raise up quicker than others. But now we kind of have the classic problem of the mushrooms. These don't look too good. We need to break them up or introduce some more noise and add some little fluffiness to them or something like that. So just get rid of this extra stuff. You press the L keyboard button to do like a quick layout macro or whatever. And then I just usually start adding forces. So this is why I like to use the smoke solver instead of the pyro solver. If you use the pyro solver, this has these shape functions built in, like a turbulence. And this turbulence setting is the same thing as using this node. But if I use this node, what I can do is do like multiple bands or multiple levels of turbulences. I could be trying out different settings one at a time and using these different nodes to like store previous values and switch back to them if I need to. It's just a bit more visual and flexible than using a parameter or a slider. And then just disabling or enabling. Visually looking at my DOP simulation, I can see I've disabled turbulence, but with this I would have to go into the shape tab and then see if it's enabled or disabled. So this is another reason why I prefer to kind of work this way. Naranjos, thank you for the Prime. These bots are doing work. I don't have to stop and shill my subscription stuff as often. Yeah, so this is the reason of just doing the turbulence that way. You could do the same thing with the pyro solver, plus you'd have to, if you needed combustion, right? You could. So this combustion, again, is another thing like that you can just work with by adding it in. I think you would want combustion in the pre-solve step. You can do the same thing with pyro, but just so I know I'm only looking in one place for these forces, like I want this parameter UI to be as simple as possible. I don't want to hunt down and be like, did I set this setting here or is it set in this place? So just visually, this combustion tab is moved to be represented by a node, and visually the shape nodes are split out into these connection representations. You double click and go inside, you can see that they've just done a very similar thing. So they have the combustion somewhere. I think they do it at the end, actually. Yeah, you could use the smoke solver for combustion. I don't really use combustion too often, but I'm generally not using the pyro solver too often unless it's like a shelf tool or something like that. But that's just because I'm kind of like OCD, or I prefer to work this way. Also, if you're moving stuff from one file to another, I can just cut these nodes, Control X, Control V, paste them and connect them. If I'm working with parameters, like I'd have to go in and individually copy paste things or whatever. It's just a weird, I'm not saying you have to work this way or it's superior. It's just it's like a personal preference basically. So we'll do turbulence in the velocity update. The one thing you do have to do if you work this way, it's kind of a pain, is like linking these OpenCL settings as you go. And then you thought there was more going on than just the gas combustion dump. There's a little bit going on. There's some stuff that they do with divergence, and like you could see inside of there, they were clearing out the divergence field before each frame. So they just set it to 0 using this node. I don't really know what's happening here. I've never really have to deal with that too much, but you can just look at here. It's just the gas combustion node, and then they're just calling this the combustion model. So it's pretty much just this node. You just have to remember to clear out divergence each frame, or you could, like, having custom control is kind of nice. You could multiply it by like 0.1 or something like that, and you could do funky stuff and get more into abstract effects or weird motion or stuff like that. But yeah, it's generally pretty simple. So I think I was using Houdini before. They had like this older Pyro solver that worked in a different way, and just like over time inspecting things, and I kind of developed my own like workflow that was slightly different than the built-in one. But I'm still using the majority, like I'm still using all of their tools. It's not like custom OTLs or whatever. So with this turbulence, I've just linked up OpenCL so it gets calculated or runs on the graphics card as well. Everything in these other settings is good. Basically, it will only introduce turbulence where there's density. So wherever we have a volume, it will start to inject turbulence or some rolling kind of motion. We might want to, sometimes I check my division size if I'm at 0.02. I want my swirl size to be roughly like 10 times that. So could just do that, 0.2. So if we move the decimal place over, it's like multiplying by 10. Now if I play the simulation again, you should start to see, just go up to frame 30. What we're doing with this turbulence is introducing smaller bubbles or smaller mushrooms. So I don't know what people tend to do. Sometimes I use this screenshot. It's just like a Linux screen capture thing or whatever. Like OS X, they have Grabber. Each operating system has its own tools for it. So I'll just make a snapshot of that and save it. And I could go turn this off and go back to frame 30. I'll just pull up that screenshot I took. So visually now we can see these two results and what the turbulence is doing. So you just using that swirl size, multiplying your division size by 10, it's a really good starting point. And we're just introducing smaller details or smaller pressure fronts, smaller mushrooms, and breaking up the big ones. So it feels a little bit more like a cumulus cloud, a little more bubbly, a little bit more gaseous than, this is more like an ink in water, or it's just kind of like, because these simulations happen within a vacuum, there's no other wind or ambient forces moving things around. So we just have to make it ourselves using the noise and everything like that. I'm also just going to go up and turn off my cache. When you're working with GPU, that makes it a bit faster to run, because the simulation cache gets stored on the RAM. You can see now that I've turned it off, I'm like kind of working in real time. You might be able to see that like over time, this is kicking in and it's just going too long and blurring things. One thing you could do is under bindings, instead of density, if you go to temperature, what this does is it will only apply turbulence where there's temperature, and the temperature is above this influence threshold. So if I go up to like 0.25, then as that temperature field cools, it will stop introducing turbulence. So it will keep things from getting too fuzzy or too chaotic. Can you tie the turbulence to temperature? So the temperature is X, multiply the turbulence. Yeah, you could do it. That's basically what I was doing there with this. This is just a threshold, so it's like a conditional statement of saying either or. Like if it's above that, do it. If not, don't do it. If you do the control settings here, then you can use the temperature and do remapping and stuff like that. It might be a little bit slower because it has to do some extra things. I usually just use this influence threshold, and this is basically density field. Is you could think of it as the influence field. So only apply turbulence where the field, this influence field, is above this threshold. Is a better way to explain it than the node UI says or whatever. Yeah. So middle mouse here, our resolution is pretty good right now for working interactively. For the final result, I might go a little bit higher, but for right now, I think it's okay. We have a pretty interesting shape. You spent that extra time doing the distortion scaling. Kind of pays off. It already feels a little interesting or kind of nice. We just want more detail. More detail. It's like always, whenever you show a volumetric simulation to a supervisor or a creative director, they'll just make it more detailed. Just increase the resolution, Pipehead. Add more detail. But that's not always the best approach. It's kind of like brute force. With disturbance, gas disturb, this is really good for adding the subtle kind of voxel-sized detail. So gas turbulence I was using and multiplying the swirl size based off of this division size like by 10. So within 10 units or 10 voxels, it introduces more detail. And then on a per voxel basis or really fine grain detail, this gas disturb does a good job of just breaking up the edges so that they aren't as crisp. So I'll just grab the OpenCL thing. Enhance. It's like all the supervisors are just sitting at the Blade Runner computer. Zoom in, frame 25, enhance, enhance. So we'll just paste our OpenCL expression. You could do a similar thing with temperature for this one, but I tend not to do that. And I think we're pretty good. They updated this node kind of recently. It's just a bit confusing with this. I think I usually leave it at continuous mode, and we can just do another kind of scrub through and just see what happens with this added. We go to frame 36. Something. Hold on. Something might be amiss. Somehow this got really slow. I don't know how that got too slow. Let me just continuous mode. I think under this continuous mode, they're running a volume of op in here. This thing. These unfortunately don't run on OpenCL. So I'm just going to have to go to block based so that it will still be pretty quick. So this is a bit odd. Sorry about that. This division size is 0.02. We just want that to be roughly our block size. So you could see before we were getting like really big spikes or swirls or stuff like that. But now when I set my block size to match the division size, this is what I was talking about with per voxel detail. We're disturbing things at like voxel scale. We're introducing different noises. It's a bit too strong, so I can just reduce the strength. If you have this thing jacked up way too high, you'll get just fuzziness, like it blurs everything. But when you start to dial it in closer to the scale or the strength that you want, then it just goes in and breaks up the edges of the volume or of the cloud. It does a really nice job at doing that. So I'm just going to go and turn off my texture resolution limit. This 3D texture just means a volume. That's what a volume is like a three-dimensional image. And by limiting it, it's saying don't display volumes higher than this resolution. And if you look at my simulation, I'm actually working at 300 by 200 by 200. So without telling me, Houdini is kind of hiding the full resolution of my volume. So it just does that because it's a bit faster to display, but if you're really interested in like what things actually look like without having to render it, this is a good way to do things. And you can maybe see like at the edges here, we're getting some weird grid artifacts. What we can do is, if you look under fields here, this actually uses an extra field called the pressure field, and the dreaded crisscross look. The grid artifacts, whatever you do, you'll always get them. This pressure field is something that gets output by the smoke solver. When it does the pressure solve and says, where is the motion heading? Where do I need to apply forces to keep things behaving like a fluid? It outputs a pressure field. And unfortunately, you can't really visualize it. They don't have a visualizer for it here. You could make one at the stop level, or you could make one here if you just do scalar field. Set this to pressure. It's already defined inside of this smoke object, so I'm not overriding it. I'm just using it to apply data. And then if I do scalar field visualization, show guide geometry to turn it on, use plane, and XY should be good. I just need to unpin myself. So now we're visualizing at the dot level, and this is showing me the slice or the values of the pressure field. So if I want to remap this range, I can change these values. But if you see a meteorologist or someone talking about a pressure front, this is what they mean is like high pressure moving, like it's disturbing other areas. This is where the forces are pushing. This is where the pressure is applied. So even though this is something that's just being provided to us as an output by the pressure solver, by the smoke solver itself, we can use it to drive or mask other forces. So for example, this disturbance, instead of uniformly adding detail to these areas, if we look at that weather desk link I did earlier, with those cumulus clouds that were evolving, like that's where the pressure is. That's where you want to add the majority of the detail. You don't want to keep like fuzzing up or doing shit to these other areas. You only want to introduce like new detail or new structures at that area. So that's what we're doing with this pressure field, or that's what we want to try to do. So right here with this guide range, we might even want to go a bit lower with it. So wherever this turns red, that means that this is reaching this value at 0.025. So if we go back to 1, it's just depends on the scale of your simulation, you know, like the units you're working at and stuff. But you just generally, it's nice to visualize it to see roughly what ranges you're working at with pressure. You could do magenta, this hidden checkbox to disable it. And again, this scalar field node here, because it already exists, we've already created a pressure field up here. This doesn't change any of the dimensions or values of it. We're just using it to attach this visualization. So now if we go back to disturb, we have the control field, and I can just type in pressure. And again, we need to go back to the lower number. I think we were at like 0.005. And I might start with a higher strength just to kind of accentuate this. I'm going to go back to the object or the geometry context, the SOP level, just so I can see the lighting and I can pin the view back here. So now if I simulate some frames, you should see like we're only adding disturbance to this area where that pressure existed. This stuff that isn't moving too fast or isn't moving too strongly doesn't get too much detail added to it. But this stuff that's moving and displacing quite a bit of forces, it will get a lot of detail or a lot of disturbance added to it. I might want to go into this look and just increase the density scale of my smoke. And sometimes with clouds, you want like a lot of density and then maybe a quarter of the shadow density. So it's kind of more like a subsurface scattering, or like the light travels further into the volumes. So you can see here, we're adding the crisscrosses, or we're adding the disturbance up here, and because there's so much motion, it's just creating more detail. But this area here is left untouched. Do you ever make a scalar field from vel length to mask disturbance or turbulence? I had done that in the past sometimes, but I tend to try to just rely on the pressure field. It's pretty close to doing the vel length. It might be the same, but because this field is provided for free by the smoke solver, you can get the other one using like this gas analysis. And then if you do length, you do speed from vel. So the length or the magnitude of your velocity vector is a speed magnitude or a scalar field. But because I have to create an extra field that generates more memory or more voxels that have to get stored on the GPU, because this pressure is already existing, it's a bit more interesting sometimes just because of the way that it's generated. So that's why I tend to work that way. Kieran, thank you. Yeah, so we just have this file is going to be a master cloud generator. We got our procedural techniques, we got our solver-based techniques. What I might do with this is maybe go up a little bit with this pressure threshold. So basically this is saying it's remapping the pressure field and then saying apply this much strength of disturbance where the pressure is at this value. So the lower I have this, it will apply disturbance everywhere. So like I was saying, we don't want to do that. We don't want this area to get as fuzzy. When you just like spatially introduce that detail where the majority of the motion is happening, you'll get a better kind of silhouette. because instead of uniformly fuzzing or blurring everything, like I was saying all along, we want to fight blurring wherever we can. So we just want to add this detail or introduce this disturbance kind of at the leading edges, or where new detail, where the turbulence is introducing more shapes, then we want to add more disturbance and add more detail in that area. So you could probably go lower with the vision size. We're moving closer to like high quality results. Again, because I'm using, you're teaching a $450 class. Yeah, I saw this earlier. I don't know, it seemed like this end result looks pretty good, but some of these stuff don't look super nice to me. I brought this up on the start of the stream, but Surgeon Aaron, he made some blog posts that I've read through. I also have my own notes and stuff that I've made clouds before for different movies and stuff. But yeah, the $400 is a bit too expensive, I think. But this guy, he has some blog posts that he typed up. I don't think he gave like HIP files, but he talks about some similar techniques. Maybe if I just go to his cloud modeling, low altitude clouds. Yeah, he talks about some similar ideas and using a pyro simulation. I think his results are a bit better, even probably than mine right now. A lot of the things we're saying might be the same, but yeah, I think this person might have just like read his article and done it. I don't know, but I'm happy to provide the knowledge wherever it is useful. Yeah. So this was trying it at a higher resolution. Might want to go a bit higher with the range of disturbance. So this way, like I'm trying to avoid getting that uniform fluffy look. That's kind of a giveaway of like CG clouds. You basically just want it to be a little bit at the top. So maybe we could do a little bit more shadows, but we just want like a hint of that detail. It's like seasoning, like salt or something. You don't want to dump it. You don't want to apply it everywhere and just spoil the meal, spoil the food. You just want a little layer, a little icing on the cake or something like that. Once we do, we're isolating just a certain section to add it to. We could then add more strength or more turbulence. Sometimes, because I'm doing clouds, like I'm not too interested in the motion right now. That's why I'm just going to certain frames. Yeah, Surgeon Aaron, I think I might have linked it earlier in this chat somewhere. Yeah, so now we have more specific areas where we're adding that. If I go up, I might want to take a look at my container. We're still staying inside of it pretty well, because we have this technique here. I promoted the noise offset at the start. If we go to different numbers, we can get different kind of arrangements or results. We can also change these noises here, like maybe this modulation. We might want to go to a bigger element size. You're basically envisioning like this white area is going to produce a fluffier cloud. Being able to sculpt things and being able to predict like what they'll evolve into is a pretty powerful skill to have. So like I was saying, if we looked earlier, we could see there's just going to be one big feature there, and now after several frames of simulation, it's kind of what we get. So it looks like maybe my turbulence might be too high, like I'm introducing too many of these small mushrooms. So I might increase the temperature influence so we create less of them. Might do a bigger swirl size, and just the overall scale, I'm gonna reduce that. So now we're, I would say, in better shape. We don't have as much of those, we just have like these bigger prominent features, and then they're getting broken up by the disturbance. And maybe my disturbance is too strong. Maybe I'll try going down to 6. So it's a pretty nice way to work here with the OpenCL stuff for the GPU. We're able to, almost as fast as like I was using the noises earlier, like change some settings, change the frame range, and get a result and see what happens. So we could just save this to disk as like a VDB file, and then instance it on a landscape or a sky, and start creating like an entire cloudscape if we wanted to. What I might do is, maybe we want to increase the cooling rate a little bit more. I'm gonna increase the swirl size a bit, and maybe the pulse length, I'm gonna make that smaller. The smoke sparse solver, I'm not using it because it doesn't support OpenCL. It can only run on the CPU, and running a simulation like this on the GPU is quicker than doing a sparse solve on the CPU from my experience. So now I think these features are a little bit better. Some of this stuff might be a bit too smooth. So I'm just going to go back to the disturbance. I'm actually just going to reduce this control range. The Goliath GPU. Yeah, I don't know. I mean, even like on my laptop, I have like a really old MacBook Pro that has like some AMD processor that works with OpenCL. It just seems like in general the CPU is always going to be pretty slow unless maybe you have like a Threadripper or something like that. So I think this is adding detail in more places that I like, but it's too strong. So I'm just going to go down to 4 for the strength. Like the resolution I was working at earlier that was like 300 by 300 by 300, you should be able to simulate a domain like that on a GTX 1070 or 1080 pretty quickly. I think the GPU stuff is still pretty useful. If you look at the Ember Gen, like online, that's a GPU solver, and it works with particles as well, and it's pretty fast. It's like a lot of the other people I've worked with in film, they'd prefer side effects to just make GPU solvers. Like the sparse solver, I don't know, might be, hopefully one day it will support OpenCL, but I have some doubts right now just about it being the fastest, because you can always do better with GPU simulations, in my opinion. So I think this is starting to look pretty good. We might maybe just want more. You go out of memory at the most interesting place, I guess. I mean, I've done I've gotten pretty good results with the 1070 doing OpenCL. Prisarn, how's it going? I mean, even right now, I'm not using that many voxels. Like, I don't want to push things too far, but I could probably go down to something like that. This is a pretty wild resolution to work at, but it will still fit. Like, I just have a really big extra kind of buffer zone with this GPU that I'm using. But a lot of the stuff that I do on the stream, it should be possible to accomplish that with a 1070. So even this crazy high resolution, like there's almost 200 million voxels, because we're sticking with the GPU, can do like 40 frames of simulation in less than a minute, which with a sparse solver, like I don't think you'd ever be able to hit that kind of speed. The GPU for just doing the same solve, like the pressure solve, and just doing it a bunch of times on the same data set is really what it's ideal for GPU stuff. It was pretty cool. I think my disturbance might still be too high. What I'm gonna do is reduce the strength to 1. The block size, I can go down because my division size went down. Clouds are so cool, I want to eat it. I'm gonna scoop, it's an ice cream scoop where it's like cotton candy. And then this pressure, I'm just gonna reduce this threshold. So with those changes, I'm basically saying apply less disturbance, but apply it in more areas. Yeah, I think clouds are always difficult to try to make because it's like such an abstract shape. Seems to me like you know you're making some good ones when you start to see other features. You're like, oh, that looks like a bunny or something. It's like naturally that's what your eye expects, is to start to see other shapes in it or stuff. If it just looks too spherical or too simple of a shape, it's harder for it to look like a cloud. So it's maybe not enough disturbance at this point. How heavy is the frame? So this, I don't know. This thing adds a ton of attributes that's taking up my middle mouse button. This, in memory, it says it's like 106 megabytes, but it's 190 million voxels. This Pyro post-process has the 16-bit float feature turned on or whatever. So if I just do save geometry, I could put this maybe just in the temporary directory, and maybe as a VDB file. So I'll save this frame, and then if I just use a file stop. So you could send this to another software if you're using like Clarice or Cinema 4D or 3ds Max. You could generate VDBs this way and give them to other people on your team or stuff like that. I should go to temp. It's like a 29 megabyte VDB file. You just read this in. Looks like with the VDB file format, your visualizations don't get saved. So it's the density or the opacity mapping is a little bit different. But yeah, I mean, that's the biggest hurdle to jump over, I guess, is like even just optimizing things so that you're not using as much memory, but it's still kind of looking pretty good. This is easy, like I was saying earlier, when the creative director comes and just says, give me more detail, it's easy to just interpret that and say, all right, let me reduce the division size. But like I was saying here, getting the ideal balance of turbulence and disturbance you can achieve a much better look just tweaking the values of them than you would ever get by decreasing the voxel division size. So I made some more changes. I'm gonna see if this gets some better results. I don't know about this. What I'm gonna do is go up here, my attribute wrangle. I think this exponential function is a bit too much. This is like a gamma value of 2. I'm just gonna go to 1.2. Basically, the more contrast you have with this power function will cause smaller areas to rise up more quickly. Reference linking the division size to block size a lot. You can do that. I tend not to do it just because then if I change the division size, like too many features of the simulation tend to change. So I prefer to work with them unlinked, but you can tie them together if you want. So I think maybe I'm seeing like too many small shapes. I'm just gonna multiply the p scale by 3 instead of 2. So all of these base particles should bleed together a little bit more. And then my turbulence, I'm just gonna go even bigger with them. Yeah, so I tend not to reference link them. Like I was saying earlier in the tutorial or in the stream, I'll take a glance at what the current division size is at and use that as a reference point for setting the values, but I tend to deviate from them pretty quickly, so I tend never to kind of link them. You could like link that and then multiply it by a value, but I find it's better just to leave them separate and not have, I don't know. I don't like it when like I change one thing and that causes a bunch of other things to change too much. This is still a bit weird. Some of the stuff is like going up too quickly. I'm just gonna go out of here. Would you consider this resolution hero shot resolution? Yeah, I'm working pretty close to something that you could think of as like a hero shot resolution. It's kind of like if you think of just two dimensions of this, like X and Y, 750 by 500. If that's going to be taking up the majority of your frame, you want it to be like close to HD resolution, like 1920 by 1080. Or if you're working at like 4K, you might need more resolution, but eventually you'll just run out of memory. But you basically never want these voxels to be rendered as like more than 8 pixels or 4 pixels or something like that. So for stuff close to the camera, you usually need a bit more detail. So what I'm gonna do here is add some roughness and change the frequencies of these textures and stuff. I think just having that big white circle in the middle was giving me too much of a fluffy, pronounced kind of detail. It's like a pressure, it's like a weird mushroom hanging out by itself. So I'm just gonna try to make a little bit more randomness in my temperature values. And then we can do another quick playthrough or advancement of the simulation and see what we got. So before that mushroom was kind of becoming like detached, just that initial starting temperature value was too differentiated from the nearby ones, so it caused a big bulb to kind of grow out of it or form. So what I did was go into my noise that's changing the color. I'm just visualizing it that way, but in this wrangle, the color is getting copied over to temperature. So we might have done too much. Now we're getting like a uniform growth of mushrooms. So I'm just gonna go back here. I'm gonna get out of this super detailed resolution. So I dropped it down and we're back at like 300 by 200. Just so I could go in more quickly and work. I think there's more of a middle ground to what I was doing. We want this stuff broken up a little bit, but I was doing too much. Maybe keep some of those, just decrease that range of things that we were deleting. So this color is just overall too bright. You do center noise, it's a bit of an issue because it's like you're getting into negative numbers. Maybe just with this remap. I kind of want to cut out some negative space so that uniformly we're not getting buoyancy everywhere. Maybe at the end, I'll just turn on this to make sure I don't have negative numbers. And then I might just go lower the element size to try to get each of these white areas are going to be individual. Mushrooms are kind of like pressure fronts. So I think maybe this P scale, making things bigger, was also something that hurt me. This is looking a little bit better. But basically before everything was going up too much, and now we have a bit more kind of contrast or areas of things that don't travel upwards or don't have buoyancy. So this I think is working a lot better. We might want to, I don't know, maybe go back with a little more contrast. I made the temperature really high there just so it's going up more quickly. Never really used Pyro Upres. Is it any good? It's okay. There's different ways to kind of do that type of stuff. There's Upres. If you go over here, there's rest fields that you can use. Like some people add some noise in the shader based off of this, or you could even do some displacement. All of that stuff, Upres or rest noises and stuff, it adds a lot of time to your overall process, just because it requires an additional step that you can't do everything in the GPU anymore. So I try to push everything as hard as I can and just get really good results out of one simulation to work like as quickly as possible. There's just been too many times where I've basically fooled around with an upres or something like that for like a week, and then you just realize like I could have just changed some settings on my base simulation and gotten stuff like looking better. So I try not to use that kind of stuff. Sometimes you might have to if like the camera's flying through stuff, but I try to stay away from that kind of stuff. So I was just going in here, you know, I wanted more darker areas, areas where things aren't lifting up as much. I think this distribution is like a weird slider, but you can use that to basically define more flat areas essentially. So this might be interesting. We can give it a play and see what happens. So this is kind of interesting. I don't know, it might be, I'm gonna get rid of that contrast stuff that I was doing. You could try some of these other noise types if you want. Sometimes Perlin is actually like a little bit better for clouds. I think the other stream from Wednesday or from Sunday I was talking about, like that alligator noise can be pretty useful with clouds. If you go down here to alligator, might need to change the remapping for this and stuff, but that alligator noise is really interesting because if you imagine it, it's kind of like a two-dimensional cumulus cloud. Like it has really nice pockets or distributions of areas and stuff that rise up more than others. I'm just going to go back to it and try to get more darker areas, more flatter kind of regions. I think I might set this minimum. Why you have listed another 1070 on Twitch info? You got more GPU. A while ago I did. I split open my computer, ripped everything out, and added another GPU. So, whoops, it's a bit odd. What was happening? I use the 1070 for just the viewport and OBS and stuff like that. And then this powerful one doesn't get used for display purposes at all. It only gets used for Redshift and OpenCL simulation. I didn't see the Redshift RT. I didn't even know this SIGGRAPH happened. I've been stuck in my head has been in the sand with this the quarantine stuff. So I might just do more disturbance here. Maybe a bit more turbulence and just see what happens. I've seen the devs on the Redshift forum kind of whispering about it and saying they're working on it and stuff, but I haven't like tried it out firsthand or anything. But like I was saying earlier, anything that helps us work more quickly is definitely something I'm excited to start using and try out. So I'm gonna make my domain a bit bigger. We're getting some artifacts or some seams visible at the edge. We'll believe it when it actually comes out. Yeah, it's always hard to Octane Brigade. What was it? I think like one of the 3ds Max renderers, like F-Storm or something. This thing is supposed to be real time, right? It was like quicker than V-Ray on the GPU. I don't know if it works with volumes, like it might just be for hard surfaces or stuff like that. But this is kind of the holy grail, is like, yeah, it's max only, but I think you might not even be able to render volumes or voxels with it and stuff. But yeah, I think a lot of the architects switched to it over V-Ray because it was like a real-time version of V-Ray almost. So this is starting to feel pretty good. Might go back to some more detail. I'd switched it to a pretty coarse or a low resolution grid just to go in and make a bunch of changes like I was wasn't looking too good. If you know you're going to have to change like a lot of settings, it doesn't really make sense to change them at such a high resolution. Yeah, so something like this could be cool. We might want more more density, like more opacity in the viewport when we look at it. And I think I might go back down with this shadow density. You can't do it in the viewport, but sometimes at render time I'll put like some blue into the shadows. You could do it maybe with like bounce lighting or something like that. I might go back to this texture here and just make it a bigger scale. Change stuff around. So this, I've kind of set this up to be like a very interactive approach of making a cloud. You kind of choose your base shape or silhouette, like two-dimensional silhouette. We might even want to maybe, if I go to this distortion amplitude, you can start to get even a more interesting shape. Like if you start to distort things more, you'll get like detached structures. That might be pretty cool to start seeing. But yeah, I think it's a pretty flexible approach for kind of working quickly or stuff like that. This is pretty nice. The Hulai clouds. Mr. Wazo, you made it. Yes, I'm just doing like a two-dimensional texture to generate source buoyancy, and then I'm just letting the clouds rise up and do what they want to do. It looks good from this angle. Yeah, I think this stuff with the isolated edges, like this could be pretty nice to start expanding the domain to fit in those disconnected chunks. Very cumulousy. So when I do this, it might be a bit too much. Having these disconnected chunks would help a lot with like using this for instancing and stuff like that. Because you start to fuzz up the edges, or this could sit well in a skyscape in a cloudscape or whatever with other clouds, because it doesn't read as like an individual shape anymore. It's something that could be fit more easily in a cloud. So you could do a lot of things here with PDG or things to turn this into a cloud generator. This GPU stuff is pretty quick, so like every 10 minutes or something like that, I could make a pretty nice cloud shape like this. So you could change the seed settings to have different outlines, change the noise distributions, and you end up with slightly different variations. They all look somewhat similar because you have the same overall buoyancy and turbulence disturbance conditions and stuff like that. But yeah, I think this is pretty cool. So you could use this for the hero cloud, or if you need animation. And then some of these scatter procedural settings for further in the distance for clouds. But you could just use this for all of them maybe. So the only things I'm really changing here is the density scale or the opacity, and then the shadow density. So I generally try with clouds to jack up the density and then reduce shadow density. So you still, if we look at the alpha channel, it still blocks most of the light, like the primary rays, but the shadows or secondary rays, you get a lot more light bleeding into the surface. You know, attempt to Haugust. Pulling tricks out like Houdini. Yeah, so it's pretty cool. What I'm gonna do here is just save this. Continued the time-honored tradition of doing an entire stream with an unsaved Houdini file. If we go up to our stream directory, we'll just do another day, another stream, another day of Hulai. This is going to be in the scenes directory, and instead of cloud noise generation, this would be cloud sim generation. So just a different technique. Real vets don't save. So this one vet, he's been saving this crash file. He just brings it around to every studio he works at. It's crash.crash.crash.crash. Auto backup. Version 30 to 8.7. So we could do a flipbook of this stuff. Maybe like 96 frames or something like that, and just kind of see how it looks in motion. Because we've been setting everything up, like looking at the start of the stream, we were examining the documents of like how the clouds rise, the temperature forms and causes them to rise up. So we've got pretty physically based settings, which means we should be able to go in and just play it in motion, and it should look pretty realistic. If you do the procedural approach, like we did on Sunday, one of the issues you might have with that is like adding animation to it or faking animation. You need to know like a lot more like tricks or weird stuff to make it look real, but the simulation technique is nice because everything's just more physically accurate. If the scene crashed, just act like the stream never happened and delete the VOD. Can't lose a stream file if there's no stream to begin with. Yeah, where did the file go? The file never existed. So you could play this back at like a slower speed. You could retime things if you really wanted it to be slow motion. I think this looks pretty realistic in terms of motion. We might want to change like the temperature cooling. The rolling's good. Yeah, that's what I was mainly focused on when I was changing the turbulence and disturbance ranges. So it's all about balancing those things to get that rolling motion. I was like focusing on that one. Whoops, not that one. The weather DAC, the meteorologist. It's all about getting that evolving, rolling kind of structures. You go back down to the bottom. My internet turned off. Got super slow. Did it even show? Weather DAC. But yeah, this kind of like evolution expansion. Mine's a lot faster. I think his is still a time lapse, but retime with the sourcing will shutter or jitter, or what you call it. Stutter or flicker. Shutter, flutter, jitter, flicker. Yeah. Yeah, it will flicker. It depends on how you add it. Basically, if you were to retime stuff, the new time blend node for Houdini, it will be able to use the velocity field to like re-advect and move the voxels around. Shutter, jitter, flicker, stutter. But yeah, the new time blend node, it doesn't really produce very much flickering. I would just do it before you convert things to VDB. It's easier for it to retime a dense grid because the voxels don't change from frame to frame. Like with this as a sparse volume, the VDB, different regions of it are voxels are activating over time. For file caching and storage and rendering, it's nice because it's optimized, but you would want to retime before you convert to a VDB. You could also, like, because we're using a GPU and all of that is so quickly, like, you might be able to change the time scale in your simulation and just do everything, like I was saying earlier about the upres, like, the fastest way to accomplish what you want is to do it all in one initial simulation. The more steps that you add, like I'm gonna fix this, doing a retime, I'm gonna fix this, doing an upres, and then the next thing you know, you have like a node graph that takes a day to cook and give you like in the new results. Like a day for 200 frames or something like that is just fixing as much as you can in the base simulation is the best way to go always. So this is pretty nice. We've kind of faked some stuff like a real cloud. Basically you have the buoyancy changes by elevation, and we've just faked it by using our cooling, the temperature cooling. But overall we're able to get a look that behaves fairly realistically. There's some more things we might want to change to get it looking better, but for the sake of today or for this stream, right now we're probably just going to leave it here. People have any more questions or more shutter, jitter, flicker terminology they want to toss out, feel free. Yeah, so it's just this time blend node. Connect it right in there, and then you could do volumes, blend mode. You could do it like by voxel position. So it should be able jitter? Jitter? You get a German guy yelling it at you and you're just like, I don't even know what is coming out of your mouth. Spaghetti? Pasta? Jitter? So advected, you can do that if you import the velocity field. But again, because you're reading and exchanging more information with the GPU and with the DOPNet, it will make things even slower. So it just keeps getting slower and slower and slower. How come your channel only has a gift to sub and not sub? I think you are already subbed, Mr. Dubtronics. Someone must have gifted you a sub already. So you are already subscribed. So I think that's why, basically once you're a subscriber, if you want to keep supporting or keep going the extra mile, you gift subs to other people in the community. But I think maybe Jeff or someone was in here going just an absolute madman gifting tons of subs, and you might have gotten one from them. If you want to continue, like, I think you click that same subscribe button and you just look at the settings for it, and it will say like when that expires. You could subscribe that way, and it would either happen in advance or like it's their terminology just gets a bit wacky because it's like they're coming up with new terms of tiers, gifters, primers, and all that Zoomer stuff. But yeah, sometimes you have to wait until like the actual day that it expires, but I think they're getting better at making it more manageable or whatever. You might be able to also go into your just like account settings, and then I think that there's a subscriptions tab or sub menu in that area, and you can like manage all your different settings and stuff there. But yeah, there might be a continue sub. There's a lot of weird stars and glitter and emotes, and it's like going back to MySpace or something like that. Zoomer. You got any Zoomers in the chat? So this one I would just switch it to voxel position to start with. Like we could try it here if we wanted to. Maybe this will do the interpolation. And now if I go to another flipbook, my range I could go by 0.1 frame. All I see are emojis flying at me. Yeah, so you could get this, where did my BTT ones? There they are. We got, I want to add more emotes. My Photoshop is a little borked right now. I was gonna add, you guys watch the GoldenEye movie? So maybe this needs to wait for another frame. We got Kim. Yeah, so you know Boris in that, he does the invincible. I had some frame grabs from that. I wanted to add some pictures of him, like after you do something successful in Houdini. I am invincible. I don't know why this doesn't look like my voxels are interpolating. It might be maybe by grid index is a better way to do it. Oh, it might be my, let me go back here. The frog emoji, does it have a meaning? It's in a weird territory. I don't think anyone knows the meaning. So I think I have to turn off these integer frame values maybe. The frog emoji is a really weird thing that happened with it or something. I think there was this, so I think it's called like the Cool Boys Club. Right? You guys, any cool boys in the chat? Maybe just boys club. Matt Fury. So he drew this. He was making a children's novel, and he drew it. And then in the last election, it got like hijacked and turned into a hate symbol, and added to like a list of bad symbology or something like that. His like entire livelihood got. Yeah, the documentary. I've seen the filmmakers from that have been doing like some interviews and stuff recently. But I mean, basically, it's just like with anything in this book, it's like anything in life. People try to use it or weaponize the meaning of it or adapt it. Like the meaning of every emoji is constantly changing and means different things at different times to different people or whatever. So I think there's like a campaign kind of now to, I don't know, like the Zoomers on Twitch who use this frog, they're not using it as a hate symbol. It's just a sign of the times or something. It's a hate symbol because certain people from the 4chan's political board took it, and then people like used it online to make political memes, and it just became associated with that. I forget the name of the guy. There was Richard Spencer or whatever, like he was wearing that pin. They were interviewing him at the time of the last election, and someone was like, bro, like what does this pin mean? Why do you have it? And when he was like checking it out and trying to tell them, this guy just ran up and punched and blindsided. Yeah, you have to be kind of careful. I mean, I don't know, as long as I'm not hurting people or promoting hate, I'm happy with what I'm doing, and I think no one will really come for me. But I think as long as you kind of follow that mindset as like you're well intentioned, you're willing to learn. If you did something wrong, it's not going to be a problem. I don't know what's happening with this time blend. I might need to do a time shift before it to lock in like these integer frames. I might go back to voxel position. You're promoting hate of your average GPU. You're doing a GPU violence. So we'll try this. I'm just gonna go by quarter frames or something to see if it works better. Houdini courses on the dark web. It's the orange web. The the intellectual orange web is just like the Houdini veterans exchanging their techniques. So it looks like this might be working now. It's hard to say. It might be just because it doesn't have enough like information to predict subframe stuff. You might want to use velocity. We got the flicker, the jitter. Yeah, I don't know. So you might want to do a different way to retime this. This is a pretty high resolution thing, so I'm not gonna try it with that. But if you go to a lower resolution, I could just do object merge, and I can just drag that. Actually worked this time. I can get the velocity field, and then if I merge it, I'm just gonna put it right there. Then I can do this advected by the velocity field. And then this should give you the no flickering or smoothing. But like I was saying with retime, like there will always be some weird interpolation or smoothing artifacts. And it's easy to go down a path where you're just wasting hours or days trying to solve artifacts and stuff like that. So that was why I was saying earlier, like if you can just do everything in the base simulation, change the time scale, get stuff looking right. If you're trying to work quickly, that's the best way to do it. Yeah, so it looks like I'm still getting some funkiness. So we could go back up here, maybe just simulation, scale time, 0.25. See what happens. So because we're doing less, I think messed up. I need to turn off this because I'm doing the time scale up here. Now when I'm flipbooking, I need to turn off my substeps or subframe flipbooks. But yeah, you would see everything's just going a lot faster. Sometimes not all of those scales of the noises and stuff like that are linked up properly. So you might get a lot different of a result. Like it looks like the turbulence and stuff like that isn't kicking in as much as it should be. But if you can, like, it's better to redial your noises and get things working better and link it up like that. It's possible you can also try like going in here on this smoke solver, going to 0.25, and then if you copy that, just reference it in the other things. I'm gonna turn this one off too. We go back to integer. That might happen. Sometimes you just need to actually change values and increase the strengths and stuff like that. But it's best, like if you know you need something simulated or the result to be more slow, to just fix it as close to the source or as close to the initial introduction of that issue instead of dealing with it. Let compositing deal with it. That's another way to do it. If you render out the motion vectors, the RSMB or whatever, then they can retime it using that information. Yeah, so this doesn't seem to work that well. We'll just go back to 1. Now if we just let another simulation go, we should be back to the good results. Give me the good settings. This is pretty good for generic clouds. Just get rid of this. This is a pretty good resolution. Like most people should, if they open up the scene with a 1070 or any GPU that has 8 GB of VRAM or more, they should be good with these settings. So we'll just go back to the start and save the file again here. And it's probably going to be it for today. Thanks for everyone coming through. We got some new subs, some new gifters, some new primers. We'll be back on Friday doing the cool zone thing. Back in the easy zone. Back in the cool zone. Thanks for everyone for hanging out, and see you guys on Friday.